write a PLC program for turning on and off of a staircase lamp using ladder logic. So we have to write a program to turn on and off a staircase lamp. Staircase lamp, how it works? One lamp will be on the staircase. You can turn on the lamp off by using two switches. Suppose you are in the ground floor, means you can toggle the switch, the lamp will glow. The lamp will glow. You can turn off here in the first floor. That is called staircase switch. How to write a PLC program to turn on and off from two different places. So two switches will be there. One will be in the ground floor, another one will be in the first floor. Let us assume it is connected to the PLC. The lamp has to be controlled. That's all. So what is, while writing a PLC program, you should be very thorough in digital electronics. Then only you can easily write the program. Here, what is the logic? Let us assume that here on, off, two states are there. Logic 1, logic 0. Here, on, off. Suppose here it is in on state, lamp will glow. Am I correct or not? Here it is in off state. Here it is in on state. That's why lamp is glowing. If you come here also if you put in on state, lamp will be turned off. Am I correct or not? Staircase switch will be like that. Here it is turned on, there it is off. There also if you turn on, turned off. So logic will be like this. Logic will be x0, x1, two inputs. Y0 will be 1. If this is 1 and this is 0, means lamp will glow. If I change this also 1, lamp will be turned off. Am I correct or not? Suppose I am coming, again another person coming from ground floor, he makes off, but it is on. Still, first floor is on. That's why it will be turned on. Suppose again he is coming to the same person now coming to the first floor, the second person coming to the first floor, and he is also making off. That's why lamp will be turned off. What is that logic? Or XOR gate. So we have to write a logic in a ladder logic program for XOR gate. That's all. AND logic means this is AND logic. This switch is closed. This switch also closed. Then lamp will be turned on. Let us assume that this is lamp. This is switch 1, switch 2. If both are turned on, lamp will be closed. Lamp will be turned on. Am I correct or not? This circuit is called OR. Already we have seen OR logic. If this is on or this is on, lamp will be turned on. Am I correct or not? So if you put two switches in parallel, then it is called OR logic. Two switches in parallel, this is called OR logic. You have to write a program for XOR logic. What is the expression for XOR logic? Let us assume that these two are AB and Y. What is the logic? AB bar plus A bar B. A bar B, that is equal to Y. You can easily write the program. If you know the logic for XOR gate, then you can easily write the program. These two are AND logic. Am I correct or not? AND, but B bar. It means you have to use normally closed. B bar means normally closed. It is like NOT gate. Bar means NOT gate. B bar means, already you know, bar means NOT gate. So normally closed contact if you use, that's all. A and B bar are in series. A, B bar are in series. A and B bar. A and B bar in series. Plus means what? Parallel. Again, A bar and B are in parallel. That's all. This is the program for ladder lodge, for staircase. That's all. Now let us check. Instead of AB, let us put X0, because in the programming we have to use X0, X1, X2, X3. That's why we'll practice instead of AB, let us prove you practice X0, X1, X2. This is X0. This is X1 bar. This is X1 bar. This is X0. Sorry. X0 bar. This is X1. That's all. Let us check whether it is working or not. Let us check. Here, what is the connection diagram? Connection diagram in the input module. Connection diagram in the input module. X0 is connected to the toggle switch, not push button. Toggle switch means we would put like this. Toggle switch means if you close, it remains closed. Remain close. If you close, remain, it becomes 1. It remains 1. So I am putting a toggle switch. One is called not push button. For this function, you need a toggle switch. Now both are open. Both are open. Both are 0. Both are 0 means X0 equal to what? 0. X1 equal to what? 1. Am I correct or not? Two switches are in series. One switch is closed, another switch open. There is no power. Come to the second line. Here if we come, X0 is open. That's why this is 1. X0 bar. But X1 is what? Again it is open. That's why there is no power. That's why lamp is off. Am I correct or not? Now, this is state 1. This is state 1. The state 2 is state 2. This is in ground floor. This is in first floor. Both are in off state. Let us assume. Now, this is X0. This is closed. And this is open. Now, he is in the ground floor. That's why this is closed. Now, lamp is, let us check whether lamp is glowing or not. X0 is 1, you know. X0 is 1. X1 bar also 1 because X1 is open. That's why that is also 1. Already I told you that if it is normally open, normally closed contact means if you give 0, it becomes 1. If you give 1, it becomes 0. So both are 1. That's why this lamp will be turned on. The lamp will be on. Am I correct or not? Now he reached the first floor. What he will do? He will close He will close X1. He will close X1. Am I correct or not? This is state 2. This is state 2. State 3. In state 3, he reached the first floor. That's why already he closed in the ground floor. Now he is going to close in the first floor also. This is X1. This is X0. Both are 1. That's why what happens in the program, X0 is 1, but X1 bar becomes 0. X1 bar becomes 0. That's why it is not working. The lamp will be turned off. Lamp will be turned off. Am I correct or not? The lamp is connected to Y0. You don't put L in the program. Put Y0. Now, another person is coming. That way only we assumed. Another person coming to the ground floor. What he will do? State 4. State 4. He will open the switch. He will open the switch. But already in the first floor, it is closed. This is X1, already this is closed. X0 is now he opened by the second person. Now what will happen? X0 is 0. Therefore, X0 is 0. Here, X0 is 0. X0 equal to 0. X1 already closed. That is also 0. Here, X1 bar, X0 bar, X0 is open. That's why this becomes 1. X1 already closed. That's why this is also 1. This way, this path is used to turn on the lamp. So second person also reached the first floor. Now he changed the state of X1. That is state 1. That is state 1. Both will be open. The lamp will not glow. This is the first experiment. Do you understand this? This you can simulate as well as you can run on a PLC. First you have to simulate. Then you have to run on the PLC. PLC will be given. In that PLC, you have to upload your program and you have to check whether it is working or not. Do you understand that? So now let us check whether it is working in simulation or not. Enter the program title and program name, file name. Both I am giving the same. Your hardware type is SA2. You can select many, but our hardware type is SA2. That's why we are selecting SA2. Module type PLC. That's all. You will get a blank page. There you have to write the program. Pick and place. So here, normally open contact is available. That is called normally open contact is required. First contact what? We put X0. Normally open contact. So let us put the normally open contact. Or you get here it is X. Name is X. Device number 0. If you use first switch, start with 0. Second switch 1, 2, 3 like that. So comment this is start button. If you want, you can give. Otherwise, no need. No, it is not start switch. Staircase switch, no need. Okay. Yes, I got X0. In series with that, normally closed contact, that is the next contact. Normally closed contact. Its name should not be X0. It should be X1. That's all. So here I need a coil, output coil. Its name is Y0. Yes, I got output coil. That's all. First part is over. Second part, second rung. The first line is called a rung. RUN. First rung is over. Second rung we have to draw. Second rung X0 bar. Normally closed contact with the same name. So normally closed contact. Already I told you that X0 means is in my image table. It is a memory. You can use any number of times. You can invert and you can use. So if you put a normally closed contact, it means you are using X0 bar. So X0 bar you need. So give X0 bar normally closed contact. Then X1 you have to use normally open. X1 you have to use normally open. Now you have to connect these two. For that, this is what? Vertical line. This is a horizontal line like that. So we put both in parallel. So XOR gate is over. Now we have to compile and test by simulation first. First we have to simulation by test. First we have to save that program. Already we gave the name. It is test2. It is saved. Now we have to compile that. Compiling completed. You can note down in the left bottom. compiled. If no error means it will be compiled. Now we have to run by simulation. If you want to upload, you have to get into communication, and that we will see later. We are not going to run in a PLC. If you want to run in a PLC, you have to upload this program into PLC. The compiled program will be uploaded into PLC. There is no need of this laptop or PC. Once it is uploaded, you can disconnect. But if you connect, the status will be reflected here. The software is written such a way that you can see the status. Whether whatever the values available, that will reflect in that variable. It is written like that. The softwares are interfacing. But once you disconnect also, it will work. Because the program is embedded into that embedded system. So now if automatically this end line will be included, or if you enter end, if you type end, it will be coming. Otherwise, if you put end, compile automatically, the end line will be included. Automatically end line will be included. Now we have to simulate. For that, here simulator. We need a simulator. Then we need a online mode to check. We need a online mode. What status of X1? Normally open, you know. That's why it gives 0. That's why it becomes 1. 1 means green. 0 means white. So now you have to run. It is in stop mode. The program is stopped. Even then, what PLC will do? Read the input image table, run the program. No program is there. Update the output image table. That automatically it will be done inside, whether you wrote program or not. That is the function of PLC. But if you upload this program, based on this program, it will do. Now you have to run that. If you run, yes, now it is in run mode. Now you can give input. There is no hardware to give input. That's why I will simulate. I am changing the value in the input image table. Here, there is no push button. I can toggle the values. I cannot use, for this program, toggle switch only required. For this program, what is required? Toggle switch. In some program, push button is required, but you cannot simulate push button. That's why what you have to do? Turn on, turn off. Push button means if you press on, release means off. If you use a toggle switch in place of push button, what you will do? On and off. Then it will be like push button. I mean, understand that? But it is toggle switch. That's why we are going to use it as a toggle switch. I am in the ground floor. It is in open. Both are open. I am set to on. Means I am turning on the switch. Lamp is turned on. Why not is 1 become? Why not becomes 1, you know? The lamp is turned on. What happens to X0 bar? 0. Now I am in the first floor. What switch is available for me? X0 or X1? X1 is available. So what I will do, you know, X1 is available, not X1 bar. X1 is available on the first floor. What I will do is, I will set this on. Lamp is turned off. Lamp is turned off. Another person is coming. Where he will come? X0 only available to him. It is in ground floor. So set off. Again, lamp is turned on. He will come to first floor. What is available to him? Not X0. X1 is available. Set off. Turned off. So it is working. You understand this? Okay. So now what you have to do, you know, you have to upload this. They will tell how to upload and all. You have to upload this. Just you have to click. It will upload into the PLC program, PLC module, and you can. There will be 2 toggle switches there. By operating that, I think it is connected to X3 and X4. Am I correct? So you have to write a program like this, X3, X4, not X0, X1. I understand this? Because the hardware is connected at X3 and X4. X0, X1, X2 is connected with push button. So it is the module available in the lab. X0, X1, X3 has push buttons. X3, X4 is connected to toggle switches. For staircase, you need a toggle switch. That's why you have to write program for X3 and X4.